You've been there, right? You ask an AI a question and it gives you this answer that sounds so polished, so confident, but it's just plain wrong. It's a huge problem, and honestly, it's what's holding AI back. Well, today, we're going to break down a brilliant new way to catch an AI in the act of, well, making stuff up. Let's get into it. And that's the real issue, isn't it? An AI doesn't really hesitate. It'll state a complete fabrication with the exact same authority as a simple, undeniable fact. This makes it so hard to trust these things for anything truly important. So, how in the world do you tell the difference? I mean, just look at this simple example. On the left, you've got a correct statement. Easy enough. On the right, you have something that's said with the same confidence, but is just completely false. This is what the experts call a hallucination, and it happens all the time. Now, the AI isn't lying like a person would. It's just generating information that doesn't match up with reality. Right, so here's the official definition. And notice, it's not about intent. It's about a mismatch with objective facts. The model cooks up something that simply isn't true, even if it's grammatically perfect and sounds totally sure of itself. And this really is the bottom line. We can't use these incredible tools for stuff like medical advice or financial planning if we can't actually trust what they say. It's a huge roadblock. But a team of researchers has come up with a really fascinating solution, and it's inspired by the way that we think. The big idea here is to stop treating the AI like some kind of magic black box. Instead, what if we started treating it more like a human brain, which, has a very distinct process for thinking about something and then speaking about it? Think about how you answer a question. You don't just blurt out the first words that come to mind. First, there's that internal reasoning process. You connect a few dots, check the facts in your memory, and you form some kind of logical conclusion. Then, and only then, do you translate that conclusion into words. It's a two-step dance. Reason, then express. So this was the huge question the researchers asked. What if we could peek inside the AI's brain during that reasoning step, before it even commits to an answer? What if we could check its logic before a single word is generated? Well, it turns out we actually can. AI models have this thing called a hidden state. And the best way to think about it is like an internal scratch pad. It's this mental space where the model organizes all the information and the logic it needs just before it spits out the final word. It's basically the AI's internal monologue. And this is where the real genius comes in. Researchers found that this internal scratch pad can actually be split into two different parts. You've got the semantic subspace, which is all about language. It's the what. It's focused on just picking the right words. But then there's the reasoning subspace, and that's where the magic is. It captures the internal logic, the why. This is the part that tells us if the AI is actually on the right track or just making things up. So how do you take this amazing idea and turn it into a real method for catching these hallucinations? Well, that's where a new framework called HARP comes in, and it's designed to do just that, to isolate and listen to that internal reasoning monologue. HARP is, of course, an acronym, and it's a bit of a mouthful, but the name tells you exactly what it does. It detects hallucinations by projecting or, focusing right on that reasoning part of the AI's internal scratch pad. Okay, so here's how it works step by step. First, HARP grabs that internal scratch pad right before a word pops out. Second, it analyzes the part of the model that's responsible for turning thoughts into words. They call it the unembedding layer, to separate the reasoning from the speaking. Third, it projects all that information onto the reasoning subspace, which is a fancy way of saying it filters out all the linguistic noise. And finally, based only on what's left, it calculates a hallucination score. If the reasoning looks shaky, that score goes way up. And this quote from the research paper, this is the whole key. The entire method works because of this one discovery, that a part of the AI's own architecture is already separating thought from speech. HARP is just cleverly taking advantage of it. Now, this all sounds incredible in theory, but does it actually work? Well, let's look at the numbers, because the results are seriously impressive. On a standard test called TriviaQA, HARP hit an accuracy score of 92.8%. For a task this tricky, that is an exceptionally high number. But here's what's even crazier. That 92.8% isn't just a high score. It's a massive leap forward. It's a full 7.5% better than the next best thing. In the world of AI research, that's not just an improvement, that's a giant jump. This table really puts it into perspective. You can see HARP way, way out in front. Other methods that look at different things like, semantic entropy, they don't even come close. HARP's approach of focusing on that reasoning space is clearly the right move.
And if you're a visual person, this chart says it all. The difference is just undeniable. That performance gap is huge, and it really puts HARP in a class of its own.
Okay, now for what might be the most incredible number of all. Just 5%. What on earth does that mean? It means HARP gets this state-of-the-art accuracy by looking at only about 5% of the AI's internal scratchpad. That's it. The reasoning signal is so clear and so powerful that it can just ignore the other 95% of noise. This makes HARP not just super accurate, but also incredibly efficient. So let's zoom out for a second. What does all of this technical wizardry really mean for the future of AI? Well, it matters because trust is everything. For AI to be truly useful in these high-stakes fields, medicine, finance, legal research, we absolutely have to be able to rely on the answers it gives us. Methods like HARP are exactly what we need to build that trust. So the big takeaway here is this. HARP isn't just some clever trick. It represents a fundamental shift in how we can monitor an AI's behavior. It's a cornerstone for building systems that are not only powerful, but also responsible and, finally, trustworthy. And that leaves us with a really fascinating final thought. Detection is the first step, right? But the researchers behind HARP even showed they could intervene and get an AI to say, I don't know, instead of just making something up. So if we can reliably spot a lie as it's being formed, what's really stopping us from building systems that can correct themselves in real time and maybe, just maybe, never lie at all?